Beneath the crowded streets of Japan lies a hidden world, a place built not for people, but for protection. Far below the surface, massive tunnels stretch into darkness. They exist silently, waiting for the moments when water becomes a threat. This underground system is one of the largest of its kind on Earth. Most people will never see it, yet millions depend on it every year.
Japan is a nation shaped by water. Mountain ranges funnel rainfall toward narrow river basins, while long coastlines expose cities to powerful storms. Each year, seasonal rains and typhoons deliver enormous volumes of water in a very short time. When rivers swell beyond their limits, the risk is not distant, it is immediate. Many of Japan's largest cities were built on low-lying plains. Some districts now sit below sea level, protected only by levees and pumping systems. In these environments, even a single night of extreme rainfall can overwhelm surface drainage. History has shown the consequences. Floods have submerged neighborhoods, halted transportation, and disrupted daily life for millions. As cities expanded, open land for water to escape quietly disappeared. Climate change has intensified this challenge. Rainfall events are becoming heavier, faster, and less predictable. Traditional flood defenses alone are no longer enough. To protect its cities without reshaping them, Japan turned underground. Deep beneath the surface, space exists where water can be stored, slowed, and safely redirected. These underground flood control systems act as silent buffers. They absorb sudden surges, control the flow, and release water only when rivers can safely carry it away. They operate out of sight, but their role is constant, not as a response to disaster, but as prevention. Hidden far below ground is a structure built on a scale rarely seen in urban infrastructure, a place designed not for people, but for water and for control. At depths reaching more than 50 meters, massive tunnels stretch for kilometers beneath the city. Each tunnel is wide enough to carry entire rivers, yet precise enough to manage flow down to the second. At the heart of the system lies an enormous underground chamber. Supported by towering concrete pillars, it functions as a pressure regulator, slowing violent surges of water before they can cause damage downstream. Every element serves a purpose. The tunnels collect overflow from multiple rivers, the chamber stabilizes that flow, and powerful pumping stations move the water safely back toward larger channels. The scale is intentional. When storms strike, water does not arrive gently. It arrives all at once. These structures are built to withstand sudden force, extreme pressure, and continuous operation. Designing such a system required absolute precision. Engineers calculated water velocity, sediment buildup, structural stress, and long-term durability. Even small errors could have catastrophic consequences. Materials were chosen for endurance. Reinforced concrete resists both time and moisture. Smooth surfaces reduce friction and turbulence, allowing water to move efficiently through the system. Despite its size, the system operates with remarkable control. Sensors monitor water levels in real time. Automation adjusts gates and pumps as conditions change above ground. This is not brute force engineering. It is controlled power. What exists beneath the city is more than infrastructure. It is a carefully balanced machine, designed to work silently, reliably, and without interruption. a reminder that some of the most advanced engineering achievements are never meant to be seen, only trusted. Constructing a system of this scale beneath an active city was an extraordinary challenge. Work had to proceed without disrupting life above ground, while excavation pushed deeper than most urban infrastructure ever attempts. The process began with precision drilling and deep shaft excavation. Circular access points were carved into the earth, reaching down through layers of soil and bedrock. These shafts became the gateways to an underground world. Tunnel boring machines followed carefully mapped paths. Slow and methodical, they advanced through the ground, removing thousands of tons of material while reinforcing tunnel walls at the same time. Space was limited. Every movement had to be planned, every measurement verified. Ventilation, structural stability, and worker safety were constant concerns. Concrete work came next. Massive pillars and chambers were poured in stages, allowing each section to cure and strengthen before the next was added. The scale demanded patience. Mistakes could not be undone. Water management during construction was critical. Groundwater seepage had to be controlled, preventing flooding before the system itself was complete. Pumps ran continuously, keeping the site dry enough to continue work. Human expertise remained essential. Engineers, technicians, and construction crews worked deep underground for extended periods, guided by detailed models and constant monitoring. The environment was harsh: humidity, darkness, confined spaces, yet progress continued, meter by meter. Years of coordinated effort transformed empty Earth into one of the most ambitious flood control systems ever built, a structure designed not for visibility, but for reliability. By the time construction was complete, what existed underground was ready to perform a task it would carry out silently, protecting the city, long after the builders had left. When heavy rain begins to fall, a system shifts from standby to action. Above ground, rivers rise quickly. Below ground, preparations are already underway. As water levels reach critical thresholds, intake gates open. Overflow is diverted away from city streets into underground channels designed to handle sudden force. Water enters fast, heavy. What could become destruction is guided into controlled pathways. The tunnels absorb the surge, preventing pressure from building where people live and work. Inside the system, flow is carefully managed. The massive central chamber slows incoming water, reducing turbulence, stabilizing pressure. This moment is critical. It transforms chaos into control. Sensors track water levels continuously. Data feeds into automated controls, adjusting gates and pumps rates in real time. Human operators oversee the process, ready to intervene if conditions change. As the storm passes, the system transitions again. Stored water is released, gradually, only when downstream rivers can safely accept it. Nothing is rushed. Timing is everything. Throughout the event, the city above may remain largely unaware. Traffic moves, lights stay on, daily life continues. This is the true measure of success: disasters that never happen, damage that never occurs. The system does not eliminate floods, it manages them, quietly, efficiently, without spectacle. When the rain finally stops, the tunnels empty. The machinery powers down. The underground returns to silence, ready for the next storm. As the climate continues to change, cities around the world face a growing challenge. Rainfall is becoming more intense, storms more unpredictable, the margin for error increasingly small. Japan's underground flood control systems offer more than protection. They offer a blueprint. Rather than fighting nature at the surface, these systems work with it, creating space for water to move safely without reshaping the cities above. The investment is significant: The engineering complex, but the cost of inaction is far greater. Urban populations continue to grow, land becomes more limited, extreme weather events are no longer rare, they are part of a new normal. What lies beneath Japan's cities demonstrates a shift in thinking, infrastructure designed not only for today's conditions, but for decades to come. These tunnels are not monuments, they are tools, built to operate quietly, without recognition, without interruption. Their success is measured not in visibility, but in absence. The absence of flooded streets, displaced families, halted cities. Around the world, engineers and planners now look underground, inspired by what has been achieved here, not to copy it exactly, but to adapt its principles to their own environments. As storms grow stronger, the need for resilient design becomes universal. The question is no longer whether cities must change, but how. Beneath Japan, one answer already exists. Out of sight, but never out of purpose.